Testing, testing, 1, 2, 3, testing.
Hello, hello, hello. All right, sorry for the delay. Head of Education Adam is not here this week, so I'm filling in. So we're gonna go over some of the announcements. So starting off, join Discord if you haven't already. Most of you probably have by now, but there's QR code, there's link. Sign in. Sign in should be open, I would assume. So go into Discord, sign in channel under management. Sign in. You need to do that to get pizza. So do that. Check the calendar for any events we have coming up. Join the mailing list. Announcements. Oh. All right, no announcements. Clap it up for the sponsors. All right, there's the socials. And if you did a co-op this summer, QR code, fill it out, helps other members of the club. White team signups are open for IRSEC, so if you didn't get blue team, or if you're not black team or anything like that, you want to do white team, it's just helping out the competition. You can sign up for that here. RVAP guest talk. So RVAP, one of the interest groups, has a guest speaker coming in. Bernard Lamp, PhD, Vice President of R&D at Magnet Forensic. He's talking about hacking IoT devices to maintain persistence. That's going to be next 2 Wednesdays from now. So 2 Wednesdays, and it'll be 6 to 8. I assume that's the normal RVAP meeting time. So if you're interested in that, go to RVAP. And that's all. Hand over to John now.
Hello, everyone. So, today we have the fun topic of core services. So, essentially what we're going to be going over here is, what are these core services? A lot of these include, Linux services, Windows services, networking, and then also some other fun, cool technologies that if you haven't heard of, you'll hear about now. And then also a little bit, kind of about the practical uses for these and everything. So this is kind of a long presentation, so strap in. There's a lot we're going to be covering today. Some will go more in depth into others about, but hopefully this will get you guys exposed to these services and get you more familiar with them. So without further ado, what is a service? What am I really going to be talking about today? So kind of on the basic level, a service is really just a piece of software that is running in the background and performing some kind of task. It could be, some sort of automation for a Git repo, or it could be responding to hardware events or listening to data from other software. It's typically loaded at startup, and it runs without any user interaction. So the first service we're going to talk about today is good old Telnet, or terminal network. So Telnet is basically a type of protocol that allows us to go from one computer, to connect from one computer to another, and send, commands through a virtual terminal over the network. So as you can imagine with Telnet, everything is done through plain text, which isn't ideal. So here's kind of a Wireshark, little bit of a Wireshark. You could see the packets of Telnet and kind of the connection there. And the important thing here is if we actually inspect out one of these network packets looks like, you can see plain text what's actually happening, what server they're accessing, the credentials they're using, all that fun stuff, which, as you can imagine, isn't great. So that's kind of where Secure Shell or SSH comes into play. And it basically ends up being a replacement for Telnet, for the HOR that is the encrypted version of Telnet. So basically with SSH, it's a secure network protocol that, same thing, will allow us to access remote computers and network. But in this case, we're able to actually encrypt that traffic, and then also, we'll handle user authentication, transfer input to the host, relay that back to the client, all in a very secure manner. So kind of one of the common files that you'll see to actually configure these, is in the etc folder /ssh/sshd config. That's your config file for the SSH daemon. And in here you can do all sorts of things. So if I skip ahead a little bit, we can change everything from like the port that this SSH server is actually listening to, and specifically, what interface, to other things such as, will we allow password authentication or not? Or do we need to authenticate, with a key? We can also change things like, the max number of tries that you get if you fail an authentication method. the max number of sessions. So maybe we want to limit how many people can SSH into this box at the same time. We could do things like that, or, change logging for debugging, and all that. So kind of the way SSH, is the first thing is, the client is going to establish a connection with our server. And then from there, what the server is going to do is it's going to generate some sort of random message. We don't really care what it is, just that it's something that we're going to send to the client. And then what the client is going to do is they're going to take that message, and then they're going to use their secret key or private key to then encrypt that message. And essentially what's going to happen is we're going to send that encrypted message back to our SSH server. And then from there, the server is going to that it has of the to use that to decrypt what the client sent it. And if all goes according to plan and the client is who they say they are, then the two messages will match. And then we'll know that, okay, authentication has passed, and then from there we can go and, the two services can decide on session key to use. And
the two is how we are establishing connections between the client and the server. So with active FTP, or I guess with both, we have what's called the command channel and then the data channel. Now, the command channel is where we're actually going to send, commands between the client and the server. So that might be, hey, start transferring this file, to the home directory for this user. Or, hey, what's the progress of this file transfer? Or maybe just stop the transfer, start the transfer, all that fun stuff. So that's going to happen in a separate connection from what's called the data channel, which is where we're actually going to be sending the data for the files that we're sending across. So with active FTP, what we're doing is we're going to have the channel for the command channel that's going to be established by the client, and then the data channel will be established by the server. And then in passive FTP, both channels will be established by the client. And kind of this diagram explains a little bit, shows a little bit more on how this works, where the client is going to connect to port 21 on the server, and then the server from there in active FTP, will then initiate a connection for that data channel on the client computer. And then passive FTP, again, the client is going to establish both connections. And the reason why there is this difference and, kind of why it's really important, and it will sort of answer this question when I say that, we only really use passive FTP nowadays. And that's because there's a pesky thing called firewalls, which, depending on who you are either, great or, terrible, because they make, lives more difficult for a lot of people. So firewalls, essentially, it could be a firewall, software that's running on the client itself. Think like Windows Defender and stuff like that. Or it could be actually, a network device. And essentially what's going to happen is if we try to use active FTP nowadays, when the server tries to establish that connection to the data channel on the client, typically that connection will fail because that will get blocked, which is kind of why passive FTP ends up being used a lot more nowadays, is because when you have the client that is establishing both connections, it's easier from a networking perspective to make that happen, because the defaults for firewalls typically block FTP and that kind of traffic. So that is FTP. But what about SFTP, or the secure version of FTP? Essentially, this is going to work exactly the same, but we're going to use our friend SSH to send the data. So this will be different from FTP's client-server direct transfer approach, where now between the two clients we're just using SSH, and all that traffic is going to be encrypted between the two, which is great. Here's another diagram that sort of high-level overview shows what's happening here with SFTP, where it really just is an encrypted tunnel where we're sending this data through. One note that I forgot to mention with FTP is kind of why we have these two separate channels to begin with. And really the main thing is kind of concurrency here, where if we're trying to send data, large files over a network, for example, we want to be able to also communicate between the client and the server while that transfer is happening. If we just use one connection, then we wouldn't be able to talk to the server until that file transfer is complete. So there's, so as you can imagine, there's a lot of benefits to having, two separate connections for that. So moving on to VNC, or virtual network computing. This is kind of when you go to the stack and then go to the console tab in OpenStack, this is essentially what you're seeing. And VNC is pretty much a cross-platform screen sharing system that allows you to remotely control another computer. So your keyboard and mouse, from your local computer can be used to control the exact keyboard and mouse of whatever remote computer you're connecting to. So typically this will just be one session. So the local user and whatever remote users are connected will see exactly the same thing. And this supports multiple operating systems, Windows, Linux, Mac OS. And one of the things with VNC and some of the other services that we're talking about today is using Shodan, for example. You can they will go and parse these open connections if they're not secured properly. So you can see this is just a regular, CentOS, Linux box. Here's a Windows box, more Windows boxes. But as we kind of get further here, it gets a little bit more interesting. Where, we can now get into, with just VNC, if it's not secured properly, other systems that we should not have access to. So looks like this is from a chemical plant or something. And it just kind of goes downhill from there. So this is kind of the important thing, is we talk about these services, and yes, knowing how they, what they do, how they work, and how to set them up is, one part of the job here. The other part is how do you actually appropriately secure it, in a manner that is appropriate for whatever the application is. So moving swiftly along from that, we're going to switch gears a little bit and talk about databases. And specifically MySQL or SQL. And basically this is MySQL specifically is a database that was created by Oracle and then released in, I believe, 2000 as open source. It's kind of interesting thing where it's mostly free, but then there are kind of like some paid services on top of it. But this is kind of one of the most common databases that you'll see. And it uses SQL, or structured query language, and databases can store pretty much whatever you want. That could be user credentials, blog articles, other text or other, file objects, or really any other data that you would need to store for an application. Typically, SQL servers listen on port 3306, and then one of the ways you can interact with them is through an SQL client, and this is where you can send, straight SQL commands, So in that example there, we are trying to delete an entry from a table called table, where the name, where that entry in the name column is equal to Dan. And then kind of the important thing to know is SQL injection. And this is kind of where if you on your front end aren't handling, or even on your back end too, aren't handling your data appropriately, if you're not sanitizing the text input that you're getting from users, it could be pretty dangerous. So if the way you are, let's say, getting information from a database is just you're taking, a string from the client and then embedding it directly into a SQL command, the client can take advantage of that. And if you are just trying, in this example, trying to find, a category where it's equal to gifts, let's say that's the input we got from our user, the user could send an input with, an add apostrophe and then add kind of whatever they want to that query. So as you can imagine, this can be very devastating and lead to all sorts of problems. So, what might seem simple on the surface can get more complex when we now stick our security hat on top of it, and kind of think of, where can things go wrong. So next thing we're going to talk about is RDP, or Remote Desktop Protocol. This was developed by Microsoft, and essentially it gives you a GUI to access a system remotely. So there's a bunch of different RDP clients you can use. You can use, the built-in Windows one, or Ramina, RDesktop. There's a bunch of them. Typically uses port 3389. And it ends up being a really convenient way, as you can imagine, to remotely access a system, different from VNC. So with VNC, how there was, just one shared session between the local user and any remote users, here we're kind of separating that out a little bit. So at least with Windows, the default implementation is it will actually, when you RDP into a machine, it will actually lock the local user out until the user is done. But that can obviously be changed, and you can have multiple users RDP into a machine at the same time. So moving on to a fun topic is DNS, or Domain Name System. And essentially what DNS does is this is the service that is responsible for taking your domain name, such as google.com or apple.com or even Bing, and taking that domain name and translating it to an IP address that your computer will understand. So the way this kind of works is there's a few different levels to it. So the first thing that's going to happen is when you try to go to, visit really any website or any domain, is your computer will first look internally into its DNS cache and say, hey, do I already know what the IP address of this domain name is? If so, I'm just going to use that until that cache entry expires, so I don't waste any time in unneeded lookups. If it's not there, then it's going to check the host file to see, okay, are there any hosts or host names to find on here with an IP address? And then after that, if it still can't find it, it will then go to whatever the default DNS server is set up on that machine. So typically, it will get the server through a process called DHCP, which is how it will actually get your client will actually get an IP address from the network automatically. Some cases, you can have this statically set. And for the most part, this ends up being your ISP's DNS server, but a lot of people often change that. So kind of with DNS, there's a few different what are called records. And this is when when you actually go look up that domain name, there's a few different information we can find about it. So A records essentially take that domain name or subdomain name and then give you the corresponding IPv4 address of the server for that domain name. Quadruple A records do the same exact thing, but for IPv6 addresses. Text records can store really just any text information. You'll commonly see this for domain verification. So let's say you're using, GitHub Pages to host a website and you want to attach a custom domain to it. Well, GitHub wants to know that you actually own that domain name. So typically what they'll have you do is add a text record to your domain, with a specific key, and then GitHub will go query that record and make sure it finds it. Other common ones you'll see is MX records. These deal with mail servers, and there's a bunch more. So going a little bit deeper into how DNS actually kind of works, how we're actually able to get an IP address there's two different processes that can be used. One is what's called a recursive resolver, and then the other is an iterative resolver. So recursive resolvers are nice because what happens is the client will go reach out to this DNS server, and then that DNS server will take care of the rest. If it doesn't know what the IP address of a domain name is, it will go to all the other name servers it needs to and get that answer for you. You're always guaranteed to either get an error or get the exact answer you're looking for. Iterative resolvers, on the other hand, are a bit more annoying because they are not guaranteeing to get you a complete answer. They'll try their best, but if they don't know the information, then they'll refer you to other DNS servers, other name servers, where they potentially might have the information. So essentially what your client has to do is the actual legwork of getting the complete answer. So it might go to it's the original DHCP server, DNS server, and that will say, hey, I don't actually know, but talk to these other servers instead. And then the client will be like, okay, let me go talk to them now, and kind of that whole process. So recursive ends up being a lot easier from a client perspective, than iterative, but they're kind of two different approaches, that you'll see. So there's a few CLI tools that you can use, which if you're dealing with, let's say you recently changed a DNS record and you're trying to test it on your machine, this is a really nifty way where you can double check, hey, are the records that my computer, that they're seeing, is the IP address correct? And you can do a lot of troubleshooting through this. So one of the ones called dig, lets you query records, same thing with NSLookup. So with dig, if you do gig google.com at an address, essentially what that command that you're seeing is doing is it's first going to look up any quadruple A records for google.com at the DNS server that you set, in this case 8888, which happens to be one of Google's DNS servers. And then NSLookup, what you're seeing there is it's running in interactive mode, and it's really just again, going to look up google.com, but instead it's going to use whatever DNS server, the computer has on file, and then it's going to just give you back A records for it. So, moving swiftly along, we have NTP, or Network Time Protocol. This is what allows us to synchronize the clock between computer systems. So, the way it works under the hood is actually pretty fascinating, and highly recommend if you're interested in this sort of thing to look it up. But essentially, it will operate over UDP on port 123, and it works in this kind of hierarchical layered system of time sources, or what are kind of called stratums. So you have stratum 0, which is referred to as like your reference clock or your master clock. And these are high precision timekeeping, like hardware devices. It could be like an atomic clock or any number of other things. Those, this is the really interesting part, is how these clocks actually work. But the kind of TLDR and summing that all up is really they'll just generate a really and very accurate pulse every second. And then that pulse typically triggers an interrupt on a computer that is directly connected to it, which we refer to as stratum 1. And then from there, that will generate a timestamp on that computer and then kind of advertise that to other NTP servers. So you kind of start from this source of truth of what the exact time is, and then from there you kind of go up these different layers, and distribute that information across entire regions in the world. So the important thing to note is, we're talking about accuracy of milliseconds over a LAN connection, and then kind of a few tens of milliseconds, over the internet. And NTP in general, and keeping, clocks synchronized is really important for a few different reasons. One is for, SSL and TLS certificates. So think like when you use a VPN or you're visiting a website over HTTPS, these certs will depend on the clocks of the systems that are using them, because certs have a particular lifetime. So if the clock on your device is off by a lot, it might appear like that certificate is expired when really it isn't. It's really just your device which has the wrong time. And then the other thing is for Active Directory. So Active Directory uses Kerberos for authentication, which is something we'll talk about in a little bit. But the important thing to note with Kerberos is that it depends widely, on the exact clock between domain controllers, clients, and servers. They really want to be as closely synchronized as possible in order for it to work correctly. And this has like a margin of about 5 minutes. Yeah, I think that's kind of all I want to say on that front. NTP is really can be really fascinating at times. So, all right, moving on to some more kind of networking related stuff. We have VPN or virtual private network. I'm sure you guys have all heard of this before and know what it is, but we'll go through it just in case. So essentially what a VPN will do is it will create a secure and encrypted connection between your device and some remote server over the internet. So depending on how you're using a VPN, this kind of has the benefits of masking your IP address, which can help in some cases with privacy, security, and confidentiality of the data that you're sending. When I say, in some cases, it kind of goes down to how you're actually using that VPN, that tunnel. So there's a few different types. There's site to site, and kind of how this works is you'll see this definitely on, more of on an enterprise level. And this is where, your company might have, like in their headquarters, their main network there, but they might also have satellite offices spread about the country or the world. And from those satellite offices, you might want to access resources, in a secure way from your headquarters, where, your entire data center is, for example. One of the ways you could do this is through a site-to-site VPN, which will, essentially act as a bridge over the internet between those two local networks. So that's site to site. The other is for remote access. So, let's say you have some services hosted in the cloud and you have some services hosted on-prem. You can use a VPN to be able to, securely access, that remote network in the cloud. And then the other one is kind of hosted, and this is the more traditional one that you probably think of, where you are able to, connect to a specific server and then have your traffic get routed, elsewhere to the internet. So common encryption algorithms you'll see will be, IPsec, SSL/TLS, or even WireGuard, and then this could be through, the actual tunneling could happen through OpenVPN, PPTP, or, IPsec or stuff like that. Looking over my notes to see if there's anything else I want to mention. I think that's kind of it for VPNs. Let's talk about mail services now, emails. So with emails and with mail in general, there's kind of the most important service you'll see is SMTP, or Simple Mail Transfer Protocol. This typically is done, lessons on port 25. I forget for SMTPS, which is, the encrypted version of SMTP. I'm forgetting what port that kind of listens on by default, but, you can look that up and see. But essentially what this service does is this is what actually processes your emails. So when you need to send a message, when you need to send an email, essentially what's going to happen is your email client is going to, through SMTP, establish a connection with a mail server. And then that mail server is going to take your email and then relay that message through SMTP to, whatever the receiving mail server is. And then from there, you kind of have two choices. You can either use POP3 or IMAP to actually get those emails from the mail server, to you. So the way POP3 works is that will download all the emails from your inbox to your local computer and then remove it from the server. Whereas IMAP is pretty much what we all mostly use. It will take those emails from the server to your inbox, but then whenever you delete one, it will then let the server know. So this lets you synchronize your inbox across many different devices, which ends up being really helpful. Trying to catch my breath here. Yes. It uses IMAP as well. It depends on how you set it up. So if you, for Thunderbird, for example, that's what I use on my computer. I'm trying to remember the onboarding process, but I believe the way I did it was, there was like an integration with Gmail. So that used, Google's APIs to kind of authenticate and connect there. But under the hood, that kind of automatically sets up your client to use IMAP. And that's kind of what you'll see as the default. I think in most situations ends up being IMAP just because that's what users are expecting. They're expecting whenever they do an action on a mail client from one device, it to also get synchronized with other devices too. But I suppose there are a few situations where people may have accidentally or intentionally, did POP3 instead. It's there for, I believe POP3 came first and then IMAP was kind of developed after that. Don't quote me on that. Definitely worth a look up and a little bit of research into that. But hopefully that answers your question. Cool. All right. Anyone else have any questions about this or other services I've talked about before? Okay. I know I'm going quickly here, but still lots to talk about. So now we get back, switching gears a little bit, to Active Directory. So Active Directory, you either love it or you hate it. And it was basically developed by Microsoft and released with Windows 2000 Server Edition. And essentially what Active Directory does is it authenticates and authorizes users within a Windows domain network. So it comes with a bunch of different services that you can use. Some of them we talked about, like, domain services, DHCP, DNS, LDAP, certificate services, bunch of different things you get with Active Directory. And kind of the important thing to know about it is that it can be very hard to manage at times, if you don't really know what you're doing. And then it can be even harder once you do understand it to, kind of appropriately secure it. We'll be talking about DHCP next, and then also LDAP will come up again. We'll talk a little bit more about that, along with Kerberos that I mentioned before. That's, Kerberos, as I said, is one of the main things that Active Directory uses under the hood for authentication. So, DHCP, or Dynamic Host Control Protocol Service. The way this works, or I guess what this does first, is this is how your device, when you connect to a Wi-Fi network or any network in general, is able to automatically get an IP address and assign it to itself. So DHCP servers typically listen on port 68, and they follow what's called the DORA process, or discover, offer, request, acknowledge. So what's going to happen here is, let's say we have a client and we have a DHCP server. The client just joined the network and they want an IP address. Cool, good for them. Let's get them one. So the first thing that they're going to do, and you can see the Wireshark, the Wireshark packets of everything that's happening here, is the first thing it's going to do is it's going to send a broadcast on the network, and this will be the DHCP discovery phase. And what's going to happen here is all the DHCP servers on the network are going to see this broadcast, and they are going to potentially do what's called, send what's called an offer, or, a packet that says, hey, here's my IP address. This is the IP that I have for you. Here's what the lease time is. So when that IP will expire, and potentially some other information too. And the client is going to take either, depending on how many DHCP servers send it offers, it'll take all those offers and then figure out which one to use. And when it does, it will send another broadcast to the network, essentially saying, hey, I'd like this IP address. And this lets all the other DHCP servers who sent an offer know, hey, I didn't accept your offer, I went with this one instead. And whatever DHCP server that originally sent that offer will see the request, and then it will send what's called an acknowledgement, basically saying, hey, I saw your request, I accept it, go ahead and use that IP address, that's okay. So, important thing here is whenever that IP address expires, or, if they potentially were to rejoin the network, there's a chance where your client will have to go through this entire process again to then get a new IP address. Okay, so that's kind of that's DHCP in a nutshell there. Wireshark can end up being really useful when you're trying to set up a DHCP server. And specifically when you have multiple servers on the same network, trying to figure out, okay, am I getting, is the IP I'm getting from this server versus another one? Wireshark can be a really handy tool to kind of figure that out and trace what's happening. So let's switch gears a little bit and talk about web. So kind of in web services, there's sort of 3 main ones you'll see, mostly 2. You have Nginx, Apache, IIS, which is, part of Windows Server. And essentially what these web services do is they will serve static web files. So this could be HTML, CSS, JavaScript, PHP, and they'll handle serving those files. Pretty much is the main thing that they do. They can also do other stuff called virtual hosting or reverse proxies. Reverse proxies we'll talk about next, but virtual hosting is pretty cool and kind of part of reverse proxies where, if we want to serve files for multiple different domains at the same time, let's say we have 3 different websites, we want to serve files for, we can use virtual hosting, what that will do is whenever it gets a request from a particular domain, it will look to see, hey, do I have, depending on your configuration, everything, it will look to see what the domain name is, and depending on that name, it will serve, different files appropriately. And then reverse proxies will potentially, I'll talk about them a little bit more, but just for now, they will go potentially to other servers on the network and then kind of take that original request, ask that server, and then get a response from that server, and then give that response back to the client. So, other things in web is proxies. So this is specifically a forward proxy. And essentially what a forward proxy does is it will sit in between one or more user devices and the internet. So instead of your client making a request directly to the internet, it will actually make the request to the forward proxy first, and then that forward proxy will make that request on behalf of the client. So this can be used to mask, who the actual originator of the request. It's generally not encrypted. And then the other thing is that forward proxies can also choose, depending on what the request is and what the response is, to either, hey, I'll allow this, request through, I'll send it, to the internet, or it might get something from the, a response back from the internet and be like, actually, I don't want to forward this to the client. Let me drop that response. So they definitely have a place, but you'll definitely see reverse proxies a lot more being used. So a reverse proxy, more in depth from what I kind of explained before, what that will do is that will sit in front of one or more web servers, and it will essentially take in requests, typically from the internet, and then it will forward those requests to the corresponding web server depending on what domain name is coming from that original request. So they're typically used for a bunch of different reasons because they enhance security, they increase performance and reliability, and then they also kind of let you expose endpoints internally on your network kind of in a secure way to the internet. So I think a good example of this is think in the case of load balancing. So some reverse proxies have load balancing capabilities, and what this means is if I get a bunch of requests, if I have 3 servers and they're all serving the same website, and I all of a sudden get a load of requests, what I can do with a reverse proxy and using like the load balancing features is I can do something called like round robin, for instance, where every time I get a request, I forward it to server 1. Then the next request I get, I'll forward it to server 2. And then, next one, server 3, and then next one after that, back to server 1. So essentially, I can distribute the requests I'm getting across multiple different servers. There's a bunch of different algorithms for load balancing, but, that can be one use case where having a reverse proxy, can be helpful. Or another one might be, let's say this service you're running, has some internal endpoints that are useful for you, to maybe be able to manage it, but you don't necessarily want those exposed over the internet. a reverse proxy can sit in front, and just handle the endpoints that you want. So one of the other things with reverse proxies too is, I mentioned Apache and Nginx before. There's another one called Caddy, and Caddy can be really useful because it will handle it will handle registering and renewing TLS and SSL certs for you. So, it will also take, that kind of manual process or potentially automated process, and, some of these will do that for you. So that is reverse proxies. Next, we got LDAP, which I kind of mentioned before. And LDAP, or Lightweight Directory Access Protocol, is basically a way where we can store users, groups, network services, and infrastructure kind of in this tree or directory-like structure. It listens on port 389, or in the case of LDAP-S, the secure version of LDAP, 636. And you'll see it a lot for sometimes with things like, single sign-on, or as I said, Active Directory. We'll use LDAP a bit sometimes. It's really helpful for, let's say you have a central, let's say you have a central server which handles all your user data and, kind of what groups they're in, what permissions they have. If you have a service that supports LDAP, what you can do is you can have that service whenever a user tries to authenticate with that service or, creates a new account. You can use LDAP to authenticate that user using, the same login credentials that they have set up on, this main authentication server. But you can also, after they log in, get information, from the LDAP server about that user, what groups they're in, and potentially, use that in your application in some way. So it's sort of there's a bunch of different protocols used for single sign-on. OIDC is one of my favorites because it's super easy to use, but LDAP can be another one in your toolbox there to handle that. So there are a few different tools that you can use with LDAP, and trust me, you will probably need to use them because at least setting up an LDAP server can be not as straightforward as you would think. At least I find myself, whenever I need to do LDAP stuff, bringing one of these tools out because there's always something wrong, or at least something I don't expect. So one of the most popular ones is LDAP search, and you can see a screenshot here which kind of shows it, where you give it, the address of your LDAP server and then kind of what you want to query. So in this case, it's really just a domain name, devconnected.com, and then from there we get an output of all the different objects that are under, that part of the that part of the tree. Another one is RPC client, but you'll definitely see LDAP search a lot. There are, of course, tools that have like a UI for this, which can also make things easier too sometimes. And then moving along to Kerberos, finally. I mentioned it before. This was developed in MIT in 1988, so it's been around for quite a bit. And basically what Kerberos does and why it's used a lot in Active Directory is it provides mutual authentication and then also some single sign-on capabilities. So it uses symmetric key cryptography, and the whole reason why it was established in the first place is think of a scenario where you are trying to authenticate with a bunch of different servers, within a particular network or domain. Now, you could, the easy approach would be, whenever I need to talk to a server, I establish a connection to the server, authenticate myself, and then do whatever I need to do. Well, that server has to know how to authenticate that client. And if we have one server which is in charge of that, let's say, in this image, it's the Windows domain controller, we don't want every single time a client needs to, authenticate with a server, that server to then immediately go to the domain controller and try to, ask, hey, are the credentials the user gave us correct? Getting a response and then relaying that back to the user. If you have a bunch of different servers and a bunch of clients all trying to do that, then that can be a lot of load on your domain controller that doesn't need to be there. So that's really what Kerberos aims to solve, is that problem of how do we authenticate with a server in a very efficient way. So the way this ends up working, I'm not going to go too much into detail because it can it can get complicated. But essentially what will happen is the client will first authenticate with the domain controller. And essentially at the end of that process, they'll get a ticket and a session key. And basically using that ticket and session key, they can then talk to and authenticate against any server in the domain, or at least under Active Directory. So instead of needing to go through this whole process with all the users authenticating with these different servers and then authenticating again with the domain controller, we can just have the user go to the domain controller once, or potentially periodically, and then be able to authenticate against any servers that they want. So ends up being pretty efficient and definitely very, very useful and handy. So next thing we're going to talk about is good old Samba. It was released after Microsoft's implementation of SMB in 1991. And it's really, what it gives you is just file and printing services. It's not too exciting by itself. It lets you store files on a file share, and then potentially, you can get printer configs from it. It's considered rather old and insecure over the internet. There's open source alternatives for Linux/Unix systems. It does have Active Directory support, which is kind of one of the claims to fame with it, is that it made doing file and printing services super easy if you're already in a Windows environment. And you can see there's a fun meme there with SMB versus SFTP, but let's move on. So some of the tools here is there's SMB client, and of course you can use Windows File Explorer to access a file share. And it's pretty straightforward. You give the IP, the address, the path to the share that you want access, and then you put in your credentials, and boom, now you can access those files. So shifting gears, we have WinRM, which is kind of interesting. And basically, this is Microsoft's implementation of kind of like remote access management for devices over a network. So what you can do with WinRM is, execute commands remotely. So a bunch of Windows operating systems have WinRM baked into it. Sometimes it may not be enabled by default. It's kind of an important thing to know there. It works over HTTP and HTTPS through those ports there. And essentially, it's kind of SSH, but for Windows machines. So you can see with the command there that all that's doing is it's going to connect to a computer called computer name, and then creating a new process running the command who am I. You'll see WinRM used quite a bit, sometimes for things like Ansible and others, kind of remote management stuff. Definitely mostly if you're in working for a company that is in a Windows environment. Typically, WinRM will be used sometimes there. So there's a bunch of other cool technologies which aren't necessarily, you wouldn't necessarily call them core services, but they're used a lot where I think we could argue nowadays they are. And one of those is Docker. And if you've gone to OpsIG before, you'll know exactly what I'm talking about. And if you haven't used Docker yet, now's the time to join OpsIG. There's my shameless plug. I think it's 6:30 to 7:30 on Tuesdays. I should know the time of my own IG, but that's besides the point. You can look on the calendar. But Docker is fantastic. Basically, what Docker will do is normally when you want to deploy, do anything, you might think, oh, I want to run this application in its own isolated environment. Let me spin up a virtual machine to do that. Well, with Docker, what we can do is we can kind of skip that whole OS level of virtualization and just use the same kernel as the host system. And then we can use what are called containers, to package up our software and run it. So containers allow us to really simplify development and then the actual deployment of different applications. So you'll typically see like Nginx, Apache, reverse proxies used a lot with Docker containers. And a lot of the services that we've talked about today can actually be ran through a Docker container too. So this diagram kind of goes over a little bit more about the specifics there of the higher level machine architecture that I'm kind of talking about, where you have your actual hardware at the bottom, and then in the case of Docker, you have your operating system. In the case of running a VM, that kind of scenario, you have your operating system also / your hypervisor, and then on top of the operating system level, you have what's called the Docker engine, and that's what's actually going to be running and managing your containers. And as you can see with Docker, we just run our apps directly in those containers. And that's pretty much it. Whereas in a hypervisor approach, again, we also have to emulate that guest operating system, which will not be as, performance just will not be the same there. So other kind of pros, as I said, is it's lighter weight, improved developer productivity, definitely more resource efficient. And kind of the main things you'll see with Docker is first and foremost the Docker file. And that is what is used to generate a container image. It's a simple text file. It contains the instructions for how to build your Docker image. And this will first stem from, hey, maybe I want to start from Ubuntu 22.04, that exact distro, and then maybe I want to install Golang on top of that. And then let me copy my application files into the container. That's what that text file is doing, is it's basically just giving us the recipe, the steps to build that container image. And then once you have that container image, that's where your actual, executable application is, along with any source code or tools, libraries, dependencies, basically everything that your application needs to be ran. Once you have that image, you can then create your container. And your container is going to be that live running instance of that Docker image. And there's a tool called Docker Compose, which you can use, which lets you specify in a YAML file, hey, here are all the containers that I have. Here are the images I want to use for them. And here's any network settings or ports, I want to expose, and maybe some storage stuff as well. But Docker Compose can be really powerful if you have an application that maybe it needs a database, then it has a reverse proxy in front of it, and then it has a backend server, then a front-end server. If you have all these different pieces, Docker Compose can be really nice because if all your different pieces are containerized, Docker Compose, with just one command, will spin all of those up for you exactly how you expect it to. So if you're working on this project and you have a teammate or a whole team of people that are also working on this project, this can be really nice because it can kind of solve that issue of, it works on my machine, but it doesn't work on your machine. Why is that? Well, with kind of this container architecture, it ends up being a bit more predictable on how things are actually set up and ran. So these images kind of show higher level overview of what I just talked about, where you have that Docker file, which is responsible for building your image. And then with that image, that Docker file and your Docker Compose file, you can then spin up your containers. There are other tools as well. I guess going back to Docker, there's one called Podman, which is very similar to Docker by Red Hat Linux, just by Red Hat. And it does essentially what Docker does, but a little bit differently under the hood, same commands and everything. It's kind of interesting. Okay, that's Docker. Switching gears, there are what are called configuration management tools. Ansible, Puppet, and Chef are some of them. And basically what these tools do is they let you really just configure and manage a bunch of servers at once. They let you automate and manage, your server infrastructure. So if you've heard of infrastructure as code before, this is what that is. So the way they work, differs from tool to tool. So in the case of Ansible, it's going to use you write what's called a playbook in YAML, and what that will do is you have the Ansible installed on your local machine, and then once you run your playbook, it will establish an SSH connection with any of the servers that you specified in what's called an inventory file, and then from there it will run your playbook. So your playbook could do anything from updating different packages you have installed to installing new ones to setting up and configuring entire applications. And if you have even just a few servers to tens or hundreds of servers, Ansible can be really powerful for that. The other one called Puppet and then also Chef as well, instead of working through SSH, actually have an agent installed on the server itself. So that's going to be a piece of software that is running and really just waiting until you tell it to do something. And that will typically work through, some sort of, REST API. And in the case of Puppet, you give it what's called a manifest. In the case of Chef, you give it a recipe. And the way those two work, I don't remember too much about Chef, but at least Puppet, the way that works is when you talk about configuration management, you'll always see come up this discussion about state. And what I mean by state is, let's say at the end of running whatever tool I want to use, I want the machine to be in a particular state. It might be that I want it to be configured a certain way, have a certain piece of software installed, but at the end of the day, I want that machine to be, in a specific configuration, a known configuration. In the case of Ansible, because it's agentless and we're just connecting through SSH, running some commands, and that's it, it's highly possible where between the time you run your Ansible playbook and maybe a few weeks go by, it's possible that your machine might end up in a different state. There could be other software that is now installed on there, and that could be through just software installing it automatically, the OS doing something, someone else logging in and doing something. The point is, when we first ran it, we got the machine to a desired configuration, and then since then it has drifted or it has changed in some way that we didn't necessarily foresee. With Puppet and Chef, what they try to do is they try to be a bit more proactive in that regard. Instead of just you run it once and then that's it, they have the agent which will look to see, okay, what is the desired state that this machine should be in? And then periodically it'll look to see if it is in that state. And if it's not, it will then try to take corrective action to get it back into that state. So if you've heard of Terraform before, that's a way where you can spin up a bunch of machines in the cloud. That also has a state issue of, okay, I deploy my infrastructure with Terraform, I get my VM in a particular state. Well, what happens if this VM is going to run for a year or even longer, and a bunch of updates go by? It could be in a very different state than what we initially wanted it to be in. So that's kind of a little bit about infrastructure as code. We talk a lot about this in OpsIG, so that's another shameless plug to come to OpsIG. So switching gears a little bit, we have something called CI/CD pipelines. And this stands for continuous integration / continuous deployment / delivery. And basically what these are is they're automations that run on our repository. So if we commit a piece of code to a repo, we can have these different automations or pipelines run and do something. So typically this could be in the case of like continuous integration. You could have it, automatically build your application to make sure, hey, can it actually build? If you have unit tests, you can have those unit tests automatically be ran. And then you can also, if you have a Docker, a Docker file in your repository, you could also have it build that Docker image and then potentially publish it to a container registry. And then in the deployment delivery phase, assuming everything is working as you would expect it, you could hit a button, and then now you could take your application and then through these automations automatically deploy it, wherever that application is going. So very cool. Lots of different things that you can do for it. Kind of the whole idea is that, we're trying to make sure that our code is as high quality as possible, before we actually deploy it, and that the deployment is consistent and automated. So it saves time for everyone. So this image shows a little bit more about that process where you have multiple developers making commits to a repository. And then you'll often see CI/CD being this cycle where, you commit some code, you build it, you run these tests, everything looks good, you deploy it, and then the next feature comes out. You commit more code, and you kind of repeat the process again and again. And if there's any failures along the way, it will let the dev team know so that they can fix it. And then once they fix it, and everything's successful, it can then go out to production. This diagram kind of also shows that as well, where we're committing this code, we're triggering these builds to happen, and then doing something based off of that outcome. It could be running more tests, or it could be sending an email, or whatever. And same thing with those tests. And then eventually, again, if everything's all correct, we might go to a staging environment. Maybe we have a separate environment for quality assurance, QA, and then finally, we could go to production. So switching gears a little bit once again, we get into microservices. And essentially what microservices are is they take one large application and then they separate it into a lot smaller and individual parts. And kind of each part has its own realm of responsibility. So take actually this will be great. So take Amazon, for instance. You have some sort of shopping platform. And then in the case of Amazon, you might have a microservice or a smaller service that handles just account information. So that could be handling, account registration, password resets, storing credentials. It could have its own databases, its own resources. But the idea is that your account service is separate and completely contained within itself and different from, maybe like the product catalog or, your users' carts or, maybe different orders. And the reason why this can be very beneficial is when you think of the issue of scale. So in the case of Amazon, you have millions and millions of users using it often at the same time. So how do you deal with, if it was all one application and maybe you just got a bunch of new signups all at once, if you want to scale that up, you'd have to make more instances of your entire application. And that could lead to a lot of resources being wasted when really you just needed your account service to be beefier. You have the more resources dedicated to it. And then the rest was fine. So in the case of when you use microservices, since they're all encapsulated, what you can do to handle that load issue is just spin up more instances of just the account service. And instead of, spinning more instances of everything else up. So that's kind of the big thing with microservices and why they can be really beneficial. And the other thing too is think of, a large dev team. If you have a bunch of different people working on one application, it can kind of be hard to manage. Whereas if you split things up into these different services, you could have smaller teams that just work on one component of that, and it can kind of make the development process a bit easier. So I know there was a lot I talked about in this presentation, but there is quite a bit that you'll see if you start looking at other repositories. For example, like CTFD, you'll notice if you look through there that a lot of what I talked about is being used in that repository. So you'll see, Docker being used with like Docker files, Docker Compose files. On that repo, they are using pipelines for automated, builds with Docker and unit tests. You'll see that there is a config for Nginx in there as well. It uses MySQL. For deployment, you might need to use SSH or, set up some DNS records to be able to go to it. A lot of what is in this presentation and why we categorize them as core services is because they just come up again and again. Sometimes for better, sometimes for worse. But if you have time, recommend looking through CTFD and kind of seeing, what sort of the services I talked about used. But we're kind of running low on time, so I'll leave that an exercise for you guys. So I know I talked a lot. Does anyone have any burning questions? No? All right. Well, thank you guys for listening. Hopefully you learned something through this. No. It's cool. Very good. Good.
Alright, demo time. So this week's demos are up. I also still have the demos from 2 weeks ago, week 5. Those are still up. They'll be up through the end of fall break, so through Tuesday. So keep working on those because I think we only have 5 solves on the hard ones that right now. It's a little tricky, but feel free to reach out if you need help. And then yeah, these ones are up as well. This week's DM is a little bit smaller than usual, so it shouldn't be too long to download. But I did post it earlier. Yeah, good luck. Let me know if you have any questions. All right. If you're doing the demos, medium one's broken, so I messed it up. I tested it last night and it worked. You got it?
There's pizza. Make sure to show your sign in. I will be checking.
ChatGPT made the news today.
Is it your laptop?
No, it's a stream laptop. Yeah. Yeah.
FM and like that.
Um, industry presenter, so Simon's here, right?
He's right there.
Yeah. He's presenting on his left side.
Yep. He's the only one. Yeah, I didn't have anyone else, but also like it's probably quick. For me, and yeah, it's gonna be long probably anyways. So. But like David said that, Do you want to start now? Or you still got to put it out? I'm gonna just put it left. Top up here. It's kind of like. Are you in the Zoom? No, okay. I just want to make sure that there's some activity because the timer might run out, and then I don't want to do. Yeah, that'd be great. That would be splendid. Yeah. Right? Yes. Okay, cool. I'm just making sure I got all the names right. So I realized since I'm using my work laptop, you're gonna have to send the Zoom link to my work email. Okay. Just because I don't have Discord or anything on there. Yeah. It's fine. So whenever you do that, let me know how you're using it. You're fine with us like streaming and recording it, right? If not, we can copy that. You guys do private videos where they're not. Yeah, we can just record it and then like. Yeah, if you, I'm comfortable with that one. Okay. You don't want us to stream it then either? You can stream it. Okay. Or is that? Yeah, it means whatever. Conflict with the... No, we can do whatever. Okay. Like, it's just I want to do whatever people are like, comfortable with. Yeah, I'd like it to be around for the club. Okay. But like we stream it to Twitch and then we just record it and upload it to YouTube. Yeah, that's fine. Okay, that's fine. So we'll just make sure to upload the video like as private or unlisted. Unlisted? Okay. Yeah. And that way people can still get it. Thank you. Yeah, no problem. Just because I didn't discuss that at all with any like leadership from my company, so I get that. No clue what the answer would be. Yeah. They're probably like big fan of the Ember and just say no, don't. So we'll just do the quiet one. You're still streaming? Is that all right? Yeah. Because like we are trying to push people to do conference talks and stuff. So like I'm equating this to that. I'll be right back. All right. 5. Huh? I don't know. This is just vaporwave or whatever. Why is it not giving me an option of sharing stuff? Why does it look like Linux? Yeah. No, it's not, bro. You're hating on me because I'm using Linux? Yeah. Maybe it's because I joined on the app, like instead of the web app. I think I normally just use the browser one.
You're good.
There we go. Why is it not screen? Yes, wow.
Yeah, is this like the feeling like an 80s hacker playlist or whatever? Is that what this is?
Looked up vaporwave, and that's what I said.
Pretty much all these songs are on the one playlist I use exclusively for doing any work. It's called like 80s, 90s, feels like a superhero or whatever.
I should just start my like Swan project right now and work on that for free.
Yeah, okay. Are you ready, Hayden?
Yeah, what time are we at? Oh yeah, we can start. Stop the music. Hello.
Hello.
Hi, Lucas. All right, guys. It's that time of meeting. Time for the research. Welcome, everyone, even though you've already been here for the past like 2 hours. So, if you're interested in presenting, fill out the form. There's still some slots in the semester. Not a ton left, but there is room. If you need ideas, check out ideas.ritsec.club. And as always, if you present or make blog posts, you'll get some cool prizes. If you're interested in blogging, there's the sign up QR code for that and the points associated with the blogs. With some quick announcements. Sign in. You've probably all done that. Join the Discord if you haven't already. Make sure to check out the calendar.ritsec.club. Join the mailing list if you haven't, mail.ritsec.club. And please, clap it up for the sponsors. Don't forget to clap it up for Sharad down there. Yeah. Okay, thank you. Make sure to check out our social medias. And for RITSEC, if you're interested in white teaming, helping out in the comp, fill out this form, join white team. Now to get into some of the cybersecurity news, I'm going to be talking about Signal introducing their post-quantum secure messaging cryptography stuff, and also an update on the Red Hat data leak that continued a bit ago. So to get into it, Signal essentially introduced a post-quantum secure messaging like system. So for all of their messages and everything now, they're quantum resistant. It's like this is like far above me. I don't know crypto, but essentially it's like using like ratcheting. So every single message is like slowly developing a new like key as it goes on. And so even if quantum computers become a problem, like this should hopefully like keep your messages safe. This Signal is like one of the first companies, at least for like messaging, to do this, which is kind of crazy. Yeah, so like it's building on their earlier protocol that they had, adding quantum resistant. Before, I don't know exactly what it was, but it wasn't. They're calling it like triple ratcheting. So it's like, yeah, like it's like this ratcheting system where as messages like are sent, the keys will slowly like change throughout it. They say like it's combining a key deviation function, so attackers must break algorithms from like each key to be able to decrypt messages. But yeah, I mean, honestly, like TLDR, not like major change on the user end, but if your messages were ever like gotten by threat actors, they wouldn't be able to decrypt it easily, or at all, pretty much. And now an update. So I think it was last week or a few weeks ago, I was talking about the Red Hat data leak, where a group named the Crimson Collectors essentially like extorted Red Hat, and they got access to like their GitLab instances, which included a bunch of like CERs, which are like customer engagement reports on like you know, network infrastructure, stuff like that. And so it was a pretty massive data breach. And so it's continued on with another group known as Shiny Hunters. I don't know where they get these names from, but essentially they're joining in on the extortion. And I did like a little bit of digging, not a ton, but they have like a pretty big history of doing stuff.
they were like involved in another one of the news that I talked about. I'm pretty sure, like the Salesforce breach that happened a while ago. But yeah, there's been like arrests going on about that. Bleeping Computer, who I cited for that bottom quote down there, says that there's been like multiple arrests over the years for these people, and they've been linked to a bunch of different attacks. So I don't think there's like a major development with them joining in the extortion, but it seems like it's definitely had a major impact, despite like Red Hat claiming that it wasn't that big of a data breach, even though it seems like it was. It was like 570 gigabytes of compressed data, so definitely more than nothing. Those are my sources, and without further ado, getting into the research is Simon. Please give him a round of applause, and thanks for him for actually coming in today. Did I?
There's 2 H's.
Yeah, you're good.
What? Are you serious?
Yeah,
I literally like.
that's all good.
I'm sorry.
I guess I have to go then.
Yeah, you can't present.
Yeah, you're not at the.
Okay, so what? You're sending me a Zoom link now? Is that what's happening?
It doesn't matter.
What's the email you want me to send it to?
S Buckheit. So my last name SBUCHHEIT at researchinnovations.com.
BUCHHEIT.
I guess.
Yeah.
Okay.
Your presentation name again, sorry.
Oh, I did have it correct in the spreadsheet. I just like didn't put it in the slides right. What?
Abbreviating it to the
Right.
Yeah, please start off there.
Yeah. Normally there's like more people, but I think this break, a lot of people got
Yeah.
home.
It's that.
Unfortunately.
A lot of people I talked to are saying that. Oh,
What do I need? When you touch me.
learn from is the process.
Well,
No, it's just I was checking to see the audio worked, right?
I don't need my video
There's no
going,
vid-
right?
no, you know.
Okay. Or
There's-
my mic, correct?
No.
Okay.
That's what this is for. There's a camera right there on this computer.
Okay.
You don't really have to say anything, but I wonder.
Alright, so I'm in.
Microphone array. What was it this? 'Cause I keep swapping it back and forth. It keeps working. But I'm just gonna keep it the way it is. I'm fine. I just I swapped the audio before.
I'm sure I might.
I can't remember if it's this one or not.
It's 88 4K audio.
It is okay.
microphone?
Yeah.
Okay. Excellent. Sorry, everybody. As if you haven't found out already, but audiovisual will always be the bane of everyone's existence in here. No matter how smart you are in whatever field you study or whatever job you go into, presentations, they'll always get you and humble you. So anyway, for those of you who don't know me, my name is Simon Buckite. I'm apparently not good at slides still. There we go. I'm an alumni from 2021. Why is this not going?
It's like slow. You gotta give it a second.
Is that slow?
No, not normally, but like.
Thank you. Yeah. Excellent.
It takes like a few seconds.
This, that is Catechus. Specifically, this is Cyber Catechus. So should I just share the other thing? It ain't changing at all. How many engineers? This is good enough. I'll just do it that way. No, it's fine. No, that's fine. I'll just do it this way. We'll do it live. It's all good. Okay, round number 3. So I graduated from RIT in 2021. I was in the BSMS program for this lovely program, Computing Security. It was great. I was a club member my entire time through RIT. Did black team for ISTS, IRSEC, did red team, did CCDC. We went to nationals and got 3rd in 2019. Went to nationals again in 2020. That was the COVID year, so it was remote and a little hit or miss on team motivation there, but I think we got 5th at nationals that year. And my hobbies, I like playing chess, compete in tournaments, go to the local club. It's a good time. Got into triathlons as well. Reading books is always good. No matter how old or young you are, I always recommend reading any books of any kind, because the more you read, the better you get at writing, the better ideas you get on the job, and it'll just improve everything over the course of your career. And I have a beautiful boy. His name is Finn. He's almost 3.5 already. It's pretty crazy how fast they grow up, but he's adorable. He's showing off his blackberry bush there. He loves the thing. He tries to eat the berries a little too early sometimes, though, so we got to keep him back away from it. But the other picture there is from CCDC Nationals in 2019. You see the lovely back of my head there. But it's a cool picture. It shows you the chaos of the team and what the Nationals looked like in that instance. It was pretty cool, though, because we entered the room, and they had massive brand new inbox Palo Alto devices, FireEye NX machines. Everything was brand new. I had to cut the shipping tape off and set up those devices if you wanted to use them in your network. So I don't know what the state of CCDC is nowadays, now that Raytheon sponsorship is a little bit shaky, but that's what it used to be, at least at the national level, so it was a good time. So real quick, I work for a company called RII, or Research Innovations Incorporated. It is one of those generic, vanilla sounding, bland engineering DoD contractor names that you would never ever hear of unless you're in the space. And unlike our name being research, we purely do offensive cyber. We don't do any research in healthcare or anything of that nature. We are primarily end-to-end cyber capabilities in both the cyber network operations space, so that's like implant development, sort of like your malware, basically what the RITSEC red team does, as well as the vulnerability research where we specialize in initial access. So our customers come and give us a target and we say, yep, we can get you in there, say no more, and we reverse engineer and develop capabilities against those targets. So the big thing with RII that keeps me there is the workplace culture. If you see along the bottom here on the slide, we've won the Great Place to Work award year over year. And I'll have to say that is single-handedly the one reason why I'm staying with this company. I've been there a little over 2 years now, and I'm obviously plugging my company because I really like working there, and I would love to have y'all come and work as well if you're into this sort of stuff that we're going to talk about today. However, no matter what job you guys get in the future, no matter what company you work for in the future, you cannot discount or care enough about the people that you will work with, okay? You can have the best work in the world, the best type of job, but if the people you interact with on a day-to-day basis make your life a living hell, it's not going to be fun, okay? If you have the worst work or not a fun job, but the team you're working with is incredible and you all get along and you love each other a lot and you support each other, every day will feel easier and every day will be better. So just please keep that in mind as you go through your career and you develop through school. The people aspect, you can never put enough importance on it. That will just make everything so much better. Anyway, enough about companies and shilling for them. We're going to move on into what we're going to talk about today, and that's what exactly is vulnerability research. Okay, so this is a question we get asked a lot in our field because you hear about it and everything like that, but we're going to talk about what actually is it. We're going to go through the process and the life cycle of it, so what doing VR on a real target's actually going to look like. We'll talk about a concrete example, how to get started, and then I'll have the token question slide at the end of every presentation you've seen. So first, like I said before, what does real VR look like? Now, moving forward, there's going to be audience participation, okay? So I would like all of you to start thinking about this question. And if anybody has and wants to volunteer what they think VR looks like, please do so now. We will not move on until someone does. What does VR look like? Yep, from VRig. Can you revise that into like corporate English so we can all understand? Specifically because I'm older and I just don't understand the lingo anymore.
It's looking for bugs and then like trying to go from there after you get initial foothold, like some kind of state corruption or like memory issue.
Okay.
In a piece of software and then cheating together an exploit to hopefully get farther access generally to the shell.
So in case any of you on this side of the room didn't hear, the summary of that answer is looking for bugs, developing an exploit, usually memory corruption, and hopefully turning that bug into some capability that will give you a shell or remote code execution. Very good. What VR looks like to me, and those of you who will get started into it, is a roller coaster of emotions. It's very frustrating. You will fight your tool chains a lot. If you try to emulate your target, you're going to struggle a lot, and you're going to fight the emulator. And then eventually you're going to come to realize that VR is really freaking hard. Okay? You're going to get a target. Any target could be the most generic piece of software, like a web server that they were talking about during education, Apache, Nginx, stuff you guys work with every day. But if I ask you to start looking into it from a security perspective and a vulnerability research perspective, the web server itself, right? You're going to have to try and set that up in a way that you can fuzz it, in a way that you can test it, and get introspection into it so that if you do find a bug, you can actually exploit that bug, right? That is going to be an incredibly frustrating process, no matter what target you choose, okay? Now, let's move away from the common example of a web server that you all know and love, and let's move into an embedded device. Can you even run the thing on your laptops? How many of you guys have an x86 machine that you use? Just an Intel processor. The majority of the room. If you have a newer MacBook, you have an AR64, an ARM64 laptop, right? But a lot of embedded devices will run on MIPS. A lot of embedded devices will also have other architectures by Texas Instruments. You all know the calculator company. They actually make chips called digital signal processors, DSP chips. Those run completely different architectures than you've ever heard of. I didn't even know those existed until I started working as a professional in this field. Okay, it broke my brain. Because we moved away from x86, MIPS, ARM, all the things that you've at least heard the word of, into this 16-bit archaic architecture that looks like it came from the 80s, but it's still being used, okay? So, that being said though, VR is extremely satisfying, okay? You saw Catechist taking the great ride on the VR roller coaster on the last slide. Those highs and lows that you experience in this field are incredible, and that's what makes it very addicting. However, it makes it very difficult to push through those lows because you're going to constantly face failure. But as you mature in the field and as you move forward into the field, you get used to that and you start accepting those challenges. Any of you guys played Dark Souls before, or Elden Ring, or any of the Souls-like games? If you've sunk more than probably an hour into it, you know what I'm talking about with facing failure repeatedly, and beating that introductory boss after 20 hours feels really freaking good, right? Vulnerability research is much the same. You're going to face those bosses that are incredibly challenging and those unique targets that make you want to quit and give up on computing. But with that, you get to exercise your creativity. You get to look at these targets from a different angle that's probably never been looked at before. And in the case of embedded targets, you're probably peeling back the curtain on some code that even the developers probably haven't looked at in years and years and years. So you're looking at you're basically like an archaeologist looking at these things, but then instead of uncovering the dinosaur bones, we uncover the software bones and then we break the crap out of them. Okay, we're not interested in preservation and showing them off in a museum. And all of those pieces together makes vulnerability research incredibly addicting to me. Now, one of the things that happens whenever a student or whoever starts getting into vulnerability research is you do these CTF challenges, right? You come here to the education portion, you listen to the talk, you learn a whole bunch, and you start doing the hands-on challenges, right? If you're used to it or if you work really hard at it, and even if you're newer into the field, they might take you the full week until the next education meeting, right? But that's only a week to do how many challenges, right? In the worst case. And then if you get into the CTFs, those are scoped in a weekend, usually like Friday midday to Sunday afternoon, right? You don't have or spend that much time on these puzzles or these challenges. Now, what you see here is an example of a real world bug and process that a coworker went through. So we see here the target, the very first point on July 2021. So the target phase here is just, he got a hold of the target. He was given the device, he's got everything he needs, he knows what he's trying to do. He's trying to find a bug, write an exploit for this device, right? The POI bullet point, that is in November, it's what, like 5 months later? Something like that. It's in my speaker notes, but I don't have them up, so math's hard on the fly. But long time later, the POI is whenever you've actually found a line of code or some feature that has a bug, right? It's a point of interest is what POI is. So it's something interesting that you're like, this is probably buggy code. This code stinks. We talk about code smells. So moving on from once you've found a place of interest, a point of interest, you move on to actually proving if that is indeed a bug or not with your POC. You develop your proof of concept to actually like crash or trigger the buggy code. We can see here this took about a month and a half from November of 2021 to January of 22 now. We're now 6 months into this process from whenever we got a target to doing the setup and all the reversing from finding a bug to now we have a POC that just kind of crashes and triggers the bug. We've now determined that it's exploitable. 6 months of work. And bear in mind, this is like full-time, 8 hours a day, 5 days, the 40 hours a week work, right? Question?
What would be like the point in time where after not finding the POC, like you just give up on it?
Yeah, so for those of you who didn't hear, the question was, at what point in time, if you don't find the POI or POC, like would you give up, right? I'll revisit that in just a second, if we'll hold it, but so here we are, January 2022. Our POC just crashes and proves the bug. Now, weaponization is where we actually take that proof of concept and we develop that into a fully functioning exploit. So think the things you would throw with Metasploit. Long time ago, back in my day, we had a lab in CSEC 101, which is now done and gone. It's like transitioned into 140, I think, and parts of it still remain possibly. We had a lab where we used Metasploit and exploited Windows XP using the Eternal Blue, the SMB buffer overflow, right? If you guys were here for the education portion, he just talked about SMB, the file sharing and printing protocol. SMB is notorious for vulnerabilities. You'll see them all the time. But Eternal Blue was one of the big ones. It is a buffer overflow in that service. Metasploit has a module for it, and you throw it and it gives you a shell back. That is what we do here in vulnerability research. We develop those exploits and those capabilities, and that is what we would consider a weaponized exploit, right? Now, if you look at the timeline here, it's pretty much a full year. For all intents and purposes, from being given a device to an actual weaponized exploit, it took a whole year. Now, maybe there was some time on and off there, right? But you can imagine maybe we say he took 3-4 weeks off, so like a month off throughout the entire process, right? But that's still 40 hours a week for a year worth of work, okay? So this is, I'm trying to illustrate that this is a long process. It's not like a CTF where you have it on a weekend or it takes you 1 week, right? Now, to answer the question of at what point would you consider stopping if you don't find anything? Well, that's gonna depend on your target space. I know it's kind of like a cop-out answer, But if you've got an incredibly complex target or an incredibly complex system, it might take you a lot longer because your setup's going to take longer. Reversing and just understanding your space is going to take longer. And you're just going to have a lot more scope to cover and understand to look for those bugs, right? However, that being said, generally speaking, if you get everything set up and working and so you can test and actually start looking for the bugs properly, if you don't find anything within that like 4 to 6 month mark, I'd say, that's really pushing it too, is like you probably need to start reevaluating either your methodology or your attack surface, which as part of the life cycle, we'll talk about attack surface enumeration. But that's kind of what I would say. Because generally finding a buggy code, it's pretty quick, especially with fuzzers these days and the capabilities that some really smart researchers and people have developed and talked about. It's usually pretty quick. Question?
Is this just like one person working on it, or is it a team?
Yeah, so in this case, I believe it was just one person and maybe one other, so like maybe 2 people on and off. But in this case, it was, we'll call it like 1.5 full-time employees, because maybe one other person was helping out. And sorry, the question was this just one person or was it a team? Another question?
Have you ever seen a target where you just haven't found any bugs and you have to go and say to the client, hey, we can't get in?
Yep, so the question was, have I ever seen, or have we as a team seen any bugs, or excuse me, any targets where there's just no bugs or we can't find anything, and we have to go back to the customer or whoever and just say, sorry boss, can't find anything, what do you want us to do? And the answer is yes, like that's a valid thing, right? Because, well, one, there's a whole thing of like being honest, not lying to your customer, and then there's like the other side that some people would argue of like, well, you don't want to say no because like there could be, right? But at the same time, you don't want to waste their money, you don't want to waste your time, okay? So the answer is yes, I've seen it, and I've even gone back to my manager or my tech lead and been like, I can't find anything. I don't know what you want me to do, what should we do? And then that you usually go into like a remediation step of kind of what I was mentioning with the timeline of not finding anything of that 4 to 6 months at the extreme. Then you start looking at your methodologies, like are you thinking about the right things? Are you looking at the attack surface correctly, et cetera, right? And I'm going through this right now with my team. We have a very difficult target, and we haven't found anything in a hot minute. And by a hot minute, I mean like 3 months. But we have ideas that we're working on still, so. I have one more timeline for you. So in the last case, it took almost a full year. Now, this one I actually worked on. This is my timeline. It's very near and dear to my heart, and it scarred me deeply. But in that scarring, I learned so much. Now, the difference here is I got the target, I got the POI, and I had the POC all on the same friggin' day, because this was an end day. For those of you who aren't aware, you all know the CVEs, the common vulnerabilities, and whatever the E stands for. CVEs come out and get assigned whenever a 0 day is then disclosed, right? And then some CVE numbering authority slaps the number and the ID on it, and then it gets published, right? So an end day just means something that was a 0 day is then announced, the public and everybody knows about it, the vendor knows about it, and basically everybody's off to the races trying to make a proof of concept exploit for these things, right? And so in this case, there was an end day. I had technical write-ups and blogs doing a technical root cause analysis with all the screenshots you could want of debuggers explaining the bug, giving me everything you'd ever want. I fully understood what was happening. I even had a script that triggered the bug and crashed the program. Awesome memory corruption. The POC crashes a program, that's exactly what we want to see, because that means there's some control flow state corruption happening, right? That means we probably can control that for our exploit and get the program to do what we want. It took me almost 6 months to turn that proof of concept into a remote code execution exploit. And I had all that stuff beforehand. This was done in a friendly debugging environment, so whenever we talk about stuff like that, this wasn't some like arcane embedded device that I had to like attach JTAG hooks to on the hardware and like go over a serial port and all this garbage, and GDB didn't work. No. This was Linux userland. GDB worked fine. Everything was good. It wasn't outdated. It wasn't too new. And it took 6 months, okay? It involved a race condition. It involved a complicated ROP chain. And it involved, I forget the third thing, but it involved a lot of pain and suffering. but you have to push through those things, okay? But this is what real VR looks like. It's not pretty, and it's not fast, okay? So anytime you see these blog posts or people talking about finding these O-days, or you read about Google Project Zero, their blog posts and these cool bugs they found, remember this, remember these timelines, because it's not a fast process, okay? Question? So the question was, did I cry tears of joy whenever I got the weaponization? Sort of. It was more of just like a finally, like I'm done looking at this stupid thing. Because again, this was 6 months of 40 plus hours a week, thinking about it when I go home, thinking about it when I wake up, constant over and over and over and over again, okay? So please just remember this anytime you see something cool. There was so much work that you did not see, okay? Now let's go to get into more of the fun things and learn something together. Let's talk about the VR life cycle, okay? And just as we just saw in those timelines, your perseverance is gonna matter more than anything in this field, okay? Because you will fail over and over and over again, but that's okay, because those that push through it get the cool blog posts and the bugs. So whenever we talk about life cycle, we kind of just saw it there on those timelines as well. We saw that you have your target selection, which isn't specifically listed here, nor on the previous one, but there was that target bullet point. So introspection and emulation on this chart here sort of covers that target selection process, okay? And then once you have your target actually selected, you're gonna go into the attack surface analysis, right? So at this point, we're still like learning about our target. We're still looking at the things about our target that are interesting from a features perspective, right? We haven't actually really gotten into that reversing, or bug finding stage yet. We're still learning. And then once we've analyzed our attack surface, then we go into the discovery phase. That's where we're gonna start doing our fuzzing, our reversing, our debugging, et cetera. And once we go into the discovery phase, we're gonna, find some bugs. Some of them will be exploitable, some of them won't, and we'll move on. And once we do find one that's exploitable and looks good, that's whenever we move into that weaponization process, making that bug and vulnerability turn into a mature exploit that we can actually leverage to something useful for ourselves or our customer, whether or not you're gonna sell it, you're gonna report it for some bug bounty, it's for your work, or you're just gonna write a cool blog post on it. Whatever your goals are, that's where you actually mature it and make it good. Now, this graphic here has this fingerprinting and reliability testing, and then it loops back around in this big old just infinity loop here. Fingerprinting and reliability testing we're not going to talk about today, but fingerprinting is essentially once you have that weaponized exploit, you probably want to make sure whatever you throw it at is vulnerable, right? Because whenever we talk about exploits, at least the ones that we're looking for, they're probably going to be 0 days when you find them, right? Ideally, right? So that means if you're throwing these exploits over the internet, especially the public internet, you better be damn sure that that's going to actually land. Otherwise, you're burning your exploit, which means you're revealing it to the entire world, or you're running a Chrome exploit in the console, and then Chromium might, collect that crash report and then fix it before you can report the bug yourself. May or may not have happened to VRig last night. Anyway, so fingerprinting is purely just identifying the targets, right? So like in the cases of Nginx or Apache, you may have noticed if you look at the HTTP headers that are returned from those web servers, they'll most often, by default, I'm pretty sure, return their versions in their headers. They'll put a server header in the response saying like Nginx or Apache, blah, 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 blah version, right? So that's a very simple way to just fingerprint them. You know what's vulnerable with your bug. Reliability testing is exactly what it sounds like. Is our exploit reliable, right? Now, the numbers that have been given to me at my company and what I always keep in the back of my head is we strive for greater than 95% reliability over like 1,000 plus runs if we can. Sometimes we can't, it's not feasible to set up a testing harness to do 1,000 plus runs because it takes 10 minutes per test, something like that, right? Especially whenever you're talking about physical embedded devices. So, and then that greater than 95%, you may be like, well, why isn't it always 100%? And then that's where I say you look at the heap exploits. The heap exploits, there's a lot of non-determinism. We're not gonna cover those at all today, but a lot of exploits just are not deterministic enough. You can't get them to 100% a lot of the time. It's great when you can, but sometimes you just can't, so you get it as high as you can. Now, let's dive into each one of those things more specifically. Target selection. This is where you're choosing your fighter. You're choosing the thing that you're going to spend the next couple months or longer looking at, right? So it would probably help to pick something you're interested in. Just a thought. You don't want to pick something that's pretty boring and you don't like, right? Because then it's kind of like that bad class. You dread going to it, right? You don't want to dread opening up your debugger or opening up your research notes. You want to be excited to look at the thing. So some things to think about is, does the target interest you? Do you use it every day? If you use the software every day, it doesn't hurt to just open that up in Ghidra or start debugging it yourself while you use it. The worst case that happens is you find a bug. Cool, you helped improve the software you use every day, right? Does the target have users? Some people are motivated by impact. If your target has no users and has like 5 GitHub stars and you find something in it, like, does it matter? Like, yeah, it may be cool research by all means, but like, you found something that nobody really knows about, it's not maintained, good practice, but again, it's all about motivation. If that motivates you, great. If not, that's fine too. And then finally, can you acquire the target? Can you buy the device? Can you get the software you need, right? If the software is expensive, maybe you go to RITSEC. Maybe they can sponsor it. I don't know what the sponsorship stuff's going on these days. You guys have a lot of cool stuff. Can you buy the hardware? Is there a specific hardware version? So a lot of companies will have global versions. They'll have like a North America version. They'll have a European version. They'll have an Asian version, right? And those might all have different firmware. They might all have slightly different features. Okay, so what do you want to target? All of these things are good to consider, okay? But at the end of the day, if you end up working for a company and this is your job, your customers are going to dictate your targets most of the time. Now, that being said, a lot of companies, including RII, have internal research and development programs because they recognize that as engineers, we like to do things that interest us and make us happy. And if we're not happy, we'll leave. Okay, so a lot of companies understand that, the good ones at least, and will let you propose your own projects and targets to a degree, right? And usually that's good for the company and for you because the company will usually roll those into programs or other projects for customers and say like, look, here's the work that we have. Our engineers are experts in this thing now. We can do that work that you want to happen, okay? So this is target selection. Any questions so far before we keep moving? Nope, cool. And then next, after you have your target, you need and must enumerate your attack surface, okay? This is like the most underappreciated steps. I'm guilty of this too, because it's super exciting to get your target and you're like, let's go. Let's hack something. Let's find a bug. Let's get the payout. Let's get the clout in the company, whatever it is. Let's do it. But if you rush into this, you're gonna miss the low-hanging fruit, okay? If any of you guys have done like web bug bounty or whatever, this is also an important step. I myself have tried web bug bounties. I'm terrible at it. Absolute trash can. Terrible. I can't do it. No, I don't have the patience for it, nor the expertise to just do black box web day after day. But some people are good at it because they understand the attack surface of these applications. They know where the problems are going to be, whether by they just know it because they've built the things before or they have a lot of experience, okay? Or sometimes they just read the docs. Reading the docs goes a long way too. RTFM, read the F manual. Use your imagination, fill in what the F is, okay? Some of the things to look at here are like your network sockets, your exposed services. If it's an actual embedded device, run Nmap on the thing, right? Pen testing's full scope here. We're trying to find exploits. Pen testing is a valid thing. The difference is if we find something, we do not write a remediation report. We don't care about fixing these bugs, right? We want the bugs to exist as long as possible so our exploits work as long as possible, okay? But all the techniques of pen testing still apply, okay? Does the thing have any web API endpoints that are suspicious, right? And then always be on the lookout for functionality that sounds inherently insecure. This quote here is not like verbatim, but I've seen it more than once where it's like, hey, we found this, we have this target, we found an API endpoint that allows you to send debug commands to it, and they're just sent straight to a shell. Literally, there is a receive call from a socket file descriptor, takes input, sends it to system. There's nothing in between. There is no filtering whatsoever. But it's okay. Only admins can access it, okay? Yeah, we'll see how that works out for that device and that target, right? Because now in your notes, and in your mind, you are one authentication bypass away from being able to have a fully functioning exploit, a fully weaponized exploit. That's pretty simple, right? Command injection, as far as exploits go, is very simple. There's no memory corruption involved, so they're very, very stable, right? So all these things you have to look at, and then this is where the creativity starts to come in and play a role too, okay? After you've enumerated your attack surface, this is where we start getting really technical, okay? We're gonna start moving into the discovery phase. This is where you're gonna start finding those POIs we saw on the timeline charts, or the points of interest, okay? This is where you're gonna start finding crashes. You're gonna start actually identifying the bugs, okay? Now, the way we identify these bugs are through two different families of techniques. You have your static analysis, and you have your dynamic analysis. Static analysis is kind of what it sounds like. It's very static. You're not running the target. You're not running anything except for the tools, okay? But the target code, if it's a binary or something, the binary is just sitting there on your disk. You're not running it. You're not interacting with it outside of just looking at it, okay? So that's gonna be your things like disassemblers, decompilers, and whatnot. So there's Binary Ninja, has a good free version now. And at RII, we are Binary Ninja Shop. All of our internal tooling is written on top of their API. Ghidra is completely free, written by the NSA. It's on GitHub. However you feel about the NSA and the government, that's on you, but you can't argue with Ghidra because their tool is phenomenal. And if we're being free, there's like no reason to really pay for it, especially, or pay for the other tools, especially as a student. That being said, Binary Ninja has a good student discount. I think it's like 70 bucks or whatever for a year license. And then there's IDA Pro. IDA Pro used to be the old guard. It's the old dog around the block. Used to be the status quo of disassemblers and decompilers. Pretty sure their decompilers still might be. However, with their pricing model and them being astronomically expensive, and Binary Ninja and Ghidra being much, much cheaper for like pretty much the same features, right? It's still an option, but there's free stuff that's really good. Then you also have your code analysis engines. So these are things like your CodeQL, running queries on your source code and whatnot, just basically looking for patterns in the code that are vulnerable. So I think if you've taken 201, they've probably talked about how memcopy can cause a buffer overflow because the size and the buffer has to all be correct. Stir copy is another culprit because there is no size check at all. It doesn't care. It'll just keep copying until a null byte, right? So you can perform these queries looking for vulnerable patterns in your target or in your code. Now, the problem with this, and you can see it on the third bullet there, is that usually requires source code. Well, that's great, Simon, but embedded devices, or most of the time we're looking at targets, they're gonna be compiled. We don't have source code. Source code is a luxury in this field, okay? Now, there has been some research and some work like around Yorn here. I forget the specific offshoot of Yorn or like the fork of it, but there is one version of Yorn for Ghidra P code, I believe. So the way the decompiler works for Ghidra is it lifts. There's a lifting process. Again, I'm trying not to stay technical, but there's a lifting process that happens, and you can run these structured queries looking for vulnerable patterns basically on the decompiled output is the gist, right? So you don't have source code, but there's still some leeway and some wiggle room there where you can run these code analysis engines on like decompiled output because it looks very C-like, right? So that's static. Oh, and I forgot to mention, we have lovely Ghidraticus right there as well. That's the Catechus and Ghidra mixing together, and he's unleashing his inner decompiler fire, smoke, breath there. So after static, we have dynamic analysis. This is probably what most of you are more familiar with, because this is like the flashy Hackerman Hollywood-style screens that you'll see. This is where you'll see GDB being used. You'll see WinDebug or x64 debug on Windows, depending on your preference. And then with GDB, you have your PwnDebug and Jeff. Those are front ends and just like plugins for GDB. They make the experience so much better. So if you've been using vanilla GDB for your classes, that's great. You know it well enough. Go install PwnDebug or Jeff now. It will make everything so much nicer than just vanilla GDB. You still need to know the commands. It's always good to know the defaults. but make your life a little easier while you're learning this stuff. Then we also have fuzzing and dynamic analysis. So fuzzing is basically just like roughly organized chaos in a way. All you're doing with fuzzing here is you're looking at those enumerated attack surfaces that you collected, and then you're going to say, okay, here's a socket that's listening, or here's a network service that takes data. We are going to scream at it and just yeet all of the data we possibly can at this thing and see what happens. Okay, it's literally like letting a little kid just smack the keyboard and see what happens, right? That's what fuzzing is. Now, that's like the very basic level fuzzing where you just take like dev-u random and you just shove the data in. There are obviously big improvements that have been made in fuzzing. So this is where you get into like all the code coverage and like how do we make a smarter fuzzer? How do we generate input that's better? Yada, 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 yada. VRig will hopefully do a talk here soon about their fuzzing work that they've been doing with V8. I've been trying to get them to do that, but they seem against it. But I'm working on it. And so with fuzzing, we have some tools like AFL++, libafl, libfuzzer. There's a whole bunch of other ones. The big thing to remember with fuzzing is that nothing will beat tailoring things to your device, right? There's a lot of plug and play with fuzzers and your targets because most of them are similar, right? But there's always going to be some amount of customization you're going to have to do, okay? And that's why we see like a bajillion forks of QEMU, which brings me to the next thing of emulation. This is where you have a target or a binary that doesn't run on your architecture. It doesn't run on your laptop or your server, right? Or you have an entire firmware blob from like a home router, for example, and you need to emulate that entire device because you want to look at the kernel exploits or you want to look at WAN side exploits, right? You want to be able to pop this thing with inbound traffic from like an ISP, right? And that's where we get into the discussion of like the botnet creations and all that stuff. But QEMU is going to be the primary tool here. QEMU is just a big old emulation framework that lets you emulate lots and lots of different stuff, and it has just as many confusing flags, if not too many. You've also got Unicorn and Box. They just all are just different APIs and different emulation frameworks that you can use to accomplish what QEMU does as well. And again here, this is not a like, oh, always pick Unicorn or always pick QEMU, right? It's going to be very dependent on what you're trying to accomplish, what's going to work easiest in your situation, and what is best for your target, right? There's a lot of cases too where you'll have an embedded device, for example, that runs a real-time operating system. All you need to know if you don't know what a real-time operating system is it's not normal Linux. There's a lot more requirements based on timing and performance that you have to meet in order to get the dang thing to even run. Okay, so that presents a problem in emulation. So real-time operating system emulation might not be even in your skill set yet, right? Because certainly not in mine. It's very difficult. There's a lot of other stuff you have to take into account. So then you have to ask, well, is what I'm interested in targeting even able to be emulated? Or can I emulate just the parts that I need? Right? So there's a lot of things that go into this. And now the most important part on this slide is that there should be a big old circular arrow going between the two, between static and dynamic. Okay, so your static should inform your dynamic analysis and your dynamic analysis should inform your static. So what I mean by that is as you, like let's say you stand up your web server or you stand up some network service that you're interested in, right? You see that there's a port listening and you throw some data at it. You just connect to it with netcat and you just start typing and hitting enter. But nothing's happening. The service isn't coming down or whatever. You don't know what this thing is. Well, now maybe you go and you open up that target in Binary Ninja, Ghidra, IDA, right? You start reversing it. You find where that socket is created, and you find where it receives the data for that socket, and you see what it does with that data. Well, now you can go back to dynamic analysis, and you can put the correct data in. And now maybe you get a message back that says, error, you can't make data properly, or you can't format data properly. And it kind of talks some smack to you because it knows what you're trying to do. That's sort of the development loop here, okay? You can't, well, sorry, I won't say you can't, because you can find a bug with just one or the other. But the best way to do it is this feedback loop, right? They should inform each other as you go through. Now, once you found something interesting, once you found a crash or you found a bug, now we go into this analysis phase. Is this thing exploitable, okay? Is this thing going to cause a crash? Are you just corrupting some memory And like, yes, that's still a bug, but like, did it crash the program when you triggered that corruption, right? Because sometimes there's bugs and you overflow a buffer or you overflow some value, but the program and service won't crash, okay? Those may or may not be exploitable, but you have to look into it, okay? And then you also have to ask yourself, how much can you control? Okay, you cannot exploit anything unless you can control some of the data, at least initially, right? And then most importantly in this step, you must identify what is called the source and the sink of your bug, okay? And the source is exactly what it sounds like. It is the beginning of the code path where your data is received from the program and then goes and ends up to the sink, which is where the bug actually happens, okay? There's a whole field within vulnerability research called taint analysis, and that's identifying data flow and figuring out ways to effectively determine the sources and sinks that could be vulnerable or could be buggy for you, okay? And then automating the process of like payload generation, okay? It's a whole thing. And with this source and sink analysis and following the data flow for the bug, you need to identify all of the idiosyncrasies associated with that code path. Okay, so that's all like the, oh, this byte gets mutated here, or, oh, this magic header must be this value, right? That's all of these little pieces here that you need to take into account. And now finally, after we've done all of that, we finally have a bug, right? We've proved it's exploitable. It crashes, it does whatever. Now we go into that weaponization step. Now, this is where the questions like, is this bug even going to be relevant in the real world come into play? Can I even groom the heap properly for a heap exploit? Okay, that's basically, do you have sufficient control of the data or the packets or however you're interacting with this program? Do you have sufficient control? And then we want to talk about continuation of execution here too. So another big difference between real world vulnerability research and the CTFs that you'll do is in a CTF, your goal is to get the flag. In a CTF, it's completely fine to throw the exploit, grab the flag, clear your shell, and then the thing is gonna segfault, right? Because you just corrupted some memory, or you needed to crash it to grab the flag, whatever it is. In the real world, maybe that system hasn't crashed in 10 years. We don't wanna crash it now. That would be suspicious. That'd be very questionable, right? Why is this thing that's been running for 10 years all of a sudden crashing with very weird log messages, right? And yeah, not only crashing, but like segfaulting, right? Big problems, big problems. So continuation of execution is not only throwing your exploit, but cleaning up your mess like your parents have asked you to do forever, right? How do you fix the program after your exploit happens to get things to continue cleanly, right? So that could be very complicated, could be a whole bunch of stuff you have to clean up, or it could be very simple, just like moving a stack pointer or something, right? But this is a very important step in the exploit development, usually why things take so much longer, right? Because we want to make this something good. Back to that eternal blue exploit I talked about, the SMB buffer overflow. Sometimes when you throw that sucker, the Windows blue screens, it falls over, okay? And I believe that's due to like some slight race condition in that exploit. I'm not 100% familiar, but that would be my assumption. Question? So the question was, since we work on a lot of embedded devices, how often do we brick them? And then I giggled a bit because we actually have a sticker called the Brick Club sticker. And whenever you brick a device, you get awarded with this wonderful honor of joining the Brick Club. And it's funny, I actually got a message from a coworker this morning. We're going through the annual review process right now. And he's like, hey, can you extend a deadline for me? Because I bricked a device this morning and I'm trying to fix it. So it happens. Okay, especially in the embedded world, especially whenever we're doing hardware stuff. And your ability to absorb bricking a device will depend on like cost, availability, and if you're doing it for your job or not. Because sometimes we get one, and our customer is like, you get one, don't break it. And so that basically takes half of our capabilities and things we usually do and just throw them in the dumpster, because like we can't even afford to try, because it would just brick the thing, okay? So that's weaponization. And again, this step, as you saw in the timelines, by far probably takes the longest, okay? It is the most arduous. It is the most not straight path thing there is. But this is where you get to exercise all of your creativity. We talk about creativity and exploitation, and this is not so much like your artistic creativity. This is more of you exercising your mastery over the technology or your mastery over your target to orchestrate this beautiful exploit and get everything to align properly and basically conduct your exploit landing, right? That's what we mean in whenever we say creativity and vulnerability research, at least to me. Maybe someone else has a different definition, but. So now that we've gone through the life cycle, we're gonna do some more fun things. I'm gonna stop talking so much, and we're gonna do a little thought experiment. So Eleanor Roosevelt has this wonderful quote that I really, really like. You must do the thing you think you cannot do. How many times have you guys read an RFC or documentation and it's like, you shouldn't do this or you can't do that? How many times? Show of hands if you've seen that before. Yeah. How many of you actually tried it? Yeah, good. Yeah, I challenge you guys to actually try it because more often than not, the developers read that too and they're like, oh, dope, nobody will do that. Because the RFC says, the standard says no one will do this, right? But what if you do? Usually bugs fall there. Whenever the RFC says you can't do something, but you do it anyway. So just keep that in mind. So let's go to something you all are very familiar with, the good old web server. You will never get away from this in school. You'll never get away from it in real life. It will always be around forever and always, both Nginx and Apache, okay? So I've already given you the target. You had no choice in the matter. Sorry, that's how school works. But whenever we talk about attack surface analysis, what are some things we should be interested in? And now I will wait. Chase, what should we be interested in? Yeah, attack surface. What endpoints? Okay. Okay, so in our lab setup, we'll probably set up a web server, listening on port 80. Maybe we just have it return a static hello world HTML page, right? Cool, pretty vanilla. You guys think there will be bugs there? I'm not belittling Chase, that was a great answer. But what are the odds that there will be bugs there? And just Docker compose up and from Nginx pull latest whatever, default Nginx Docker command. Probably not likely, yeah? So what are some other attack surfaces you guys think might exist? Yeah.
Are there like websites running, like any spot on the website where you can like enter anything?
Like XSS or like server-side request forgery, things like that. So I agree with you, great answer, but we're interested in the web server itself, not the application that it's hosting. So in Chase's example, whenever he talks about returning just static HTML back, that's great. But I'm interested and for testing the web server, that's good because we're not interested in that back-end application behind the web server. We're interested in Nginx itself or Apache itself. Yes? Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Yeah, like puny code type stuff too. All right, I don't know if that's more of a DNS thing, but yeah, I see where you're going. So. Mm-hmm. Mm-hmm. Yeah, so the answer that was just given was looking at like hostname validation, or you configure these things with virtual host, I think was mentioned as well with Apache. So the web server has to do some kind of processing with that, no? Right? It's got to do some sort of checking and parsing. So maybe there's some problems there, right? Good, very good. I like that idea. Yeah, that was good, and I don't even remember the other things that I was going to say. So yeah, we'll go with that. So after we do our attack surface enumeration, we now have our stuff to look at, whether that's the host name parsing or what have you. Now we're going to go into the discovery process. What should we do first? I see two VRig people who have not raised their hands. Yep, what's up?
You want to start poking stuff? See like how it reacts?
What stuff?
Like any of those possible attack surfaces.
Okay, and then how are we going to watch how it reacts? There's not really a wrong answer.
Yeah,
so.
I guess just like you said before, like fuzzing, see if anything is weird.
Yeah.
Weird inputs, weird outputs.
Yeah, so once we identify the attack surfaces, we just want to give it whatever input it needs, right? And we're just going to watch what happens. That could be in the Nginx logs or the Apache logs. It's got both a normal log, and then they usually both have their specific error logs, right? We're just going to look at it and see if the thing falls over. We're going to look at it, and in the case earlier with the attack surface enumeration and looking at like hostname validation or things like that, maybe we can look at if our requests bypass that filter, right? Because that's still a bug. It may not be the flashy exploit everybody knows and loves, but that's still a bug. That's still payoutable, right? You're bypassing a filter that some places rely on for security, okay? And now, okay, we've done our attack surface, we've done our discovery. We found something interesting. Maybe it's crashing and whatnot. Okay, so now we go into our weaponization process. Okay, what are some areas? Now this is going to be like a difficult question for me to ask, so bear with me. Weaponization is difficult. We've established that. So with our web server example, where are some things or places we can look to be creative, right? We talked about that creativity a little bit. Where can we be creative to like maybe tweak the application in a way or understand the application in a way that will help us direct our exploit now in the context of web servers? We can wait. Thank you. Yep. Instrument it with a plugin. Okay. Yeah. What would you do with that? Mm-hmm. 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 Yeah, absolutely. So the plugin thing, I really like it, especially in the discovery phase. That's great. But also, not just developing our own plugin, but looking at the plugins that are available. So for those of you who don't know, Apache is really famous for this, like mod auth or whatever. They call them plugins. I think Nginx does them too, but they're a slightly different way possibly. But that's besides the point. There are plugins available for these web servers that could introduce different behavior. They could introduce desirable behavior. What if you can enable one with your exploit, right? What if you have just enough of a primitive you can turn a plugin on that already has a CVE and a known exploit? Well, now you can just use someone else's work. Easy mode, right? So that's what that creativity part is about, right? It's not just, how do I get control of the program counter and execute my own code? It's, can I turn something else on that's more vulnerable and that I can then attack from what little bits I have? Right? So all of these things, it's just a very, very quick example of like all the things that you would think about, right? Now, very quickly, because I recognize it's already going on for a while, my apologies. But how to get started, okay? You got to just take that first step, as MOK said. So the fundamentals, I cannot stress this enough. I've been asked a lot because it's Career Fair week, you know, what's most important to study? What do you look for in a candidate? This, okay? I can't even stress enough. This one slide, if you were to take a picture of anything, the things to study if you're interested in this field, your fundamentals, okay? I can teach you how to hack things. I can teach you how all the exploitation techniques work, okay? But if you do not understand the fundamentals of memory, of how programs get executed, of the registers of the architecture that you are interested in learning first, I cannot teach you those things. Okay, it won't happen. In a career setting, of course. Obviously, if you're in school and like say I was a professor or something, like teaching you those things is different, right? But in a career setting, if you do not have your fundamentals, this goes for pen testing, this goes for whatever you're trying to do, find out what the fundamentals are and master them. Your interviews will go easier. You will stand out a lot more for the candidates because you'll be, you know, younger, but you have mastery over these basic things. So they'll be like, oh my God, this person's great. Right? Cannot stress this enough. Now, networking makes an appearance here with a little asterisk because for vulnerability research, at least at the outset, whenever you're learning, it's not as important to understand the networking stuff. I put it up here because networking is single-handedly the most universally important skill across all of the technical domains. Hands down. If you're a developer and you can debug DNS, you'll look like a god in your office. Okay? If you can understand networking protocols in your software development team, people will be freaking out, except for the seniors, because they'll be like, oh, it took me so long to learn those on the job. Okay? Networking is important too, but not, at least not whenever you start with these things, okay? Now, in terms of other things to do, I mentioned CTFs, and it might have seemed like I was ragging on them a little bit, but nothing can beat the hands-on practice, especially in this field, unfortunately, okay? The more time you spend looking at GDB and the more time you spend looking at the matrix of hex in front of you and being able to just read bytes and just look at a mess of bytes and say, oh, that's ASCII, of course, duh. Don't you just see that? Okay? The more you do that, the more comfortable you get, and you can focus on the littler things of mastery and the fundamentals, okay? Now, Pone College, hands down the best resource. It's free, it's put on by Arizona State University. There are some legends that teach there and put on courses for this. Pone College is completely free. They have their lecture material all published and available on YouTube. They have all of their challenges and homework available, and you get access to the same Discord as the students. The only difference in the Discord is you don't get access to the channel for the class, but you have access to the Discord, which gives you access to the same TAs, the same professors, right? The same people who have gone through the class. Pone College is phenomenal, and it's completely free. Replicating end days is probably the other thing. So once you get going in these CTFs and you feel a little better, and you see an end day or some write-up that's really interesting and cool, go grab that version of the software and start doing the same thing. The benefit of this is you already have public knowledge and information to draw on if you get stuck, okay? You have people and blog posts, hopefully, that show you the way to go, right? So this is also really good, especially if you're looking at a new target space you're unfamiliar with. And just personal projects. You choose your own adventure, but just don't go to jail. Okay, that's the important part too. And then finally, this is just some of the resources if y'all want to take a picture or whatnot. I believe this will be saved and available afterwards, a private thing. So if I don't know how it works for RITSEC, but you can get the link for it somehow to rewatch and come back to this slide. And finally, your very own Chase Killoran has been working on his wordsmithing and begged me for a slide. So I decided to let him. But essentially what Chase is telling us here is you have to struggle, okay? And you're in whatever field, whatever area of CSEC or CS, SWEN, whatever, you must struggle, okay? You must suffer to learn. It's just how it is, okay? You look at the people, the fourth years who are like cracked out of their minds, and you're like, how can I get there? Well, it's because they spent hours debugging things that you just haven't encountered yet. Or you have encountered them, but you haven't encountered them the 500 or 600 times that they have, okay? So be patient, deal with the failure, you'll get there, okay? And then finally, just be curious. Things aren't impossible, okay? They're just hard. You'll hear this on your teams as you go out into industry. Somebody will say or suggest an idea, maybe it's you, and someone will go, oh, that's impossible, okay? No, it's not. They just don't want to do the work for it, okay? Again, think back to the timelines I showed you at the beginning. How many people would have given up after 3 months, 4 months, 5 months, 6 months? You have 6 more months of work ahead of you, but it looks like you have 1 week, right? How many people give up? So you just have to keep going. And with that, I'm done. Any questions? Last questions? No? Nada. Cool. Well, thank you, everybody. Take care. Oh, beautiful. Oh, thanks, man.
Thanks, I guess. Thank you, Simon.
Yeah, of course.
Thank you. It was really good.
Yeah, thanks, guys.
And with that, we are done for today. Thank you, everyone, for coming here. This was a fantastic presentation. I hope to see you all again next week. Enjoy your break very much. Thank you. Bye, stream. Yeah. If you opened up one of the wells in the ground to plug in your computers, please make sure that you close them. Thank you.